Alright guys, I'm back with the second video on React2Shell, and in this video, let's look at how this exploit exactly works. I spent a lot of time understanding the details of React works. And to be honest, I'm not really impressed on the code quality as well as, how the attack actually plays out, because the code that you will see in this video about how React Server Components works is slightly bad in my opinion, because it involves a lot of trust on the data that the user is sending in the first place, right? The property access and the property set mostly, right? And that is where the vulnerability also comes into picture. But I'll show you how everything works, because now I have gone through this entire code base, or at least the relevant parts in React's framework, and I'm going to show you what exactly happens, like what's going on over here. So we are not going to go into the proof of concepts that other people have released. We're going to create our own proof of concept, and I'm going to start by saying that in order to run this, you need to have a React version which is vulnerable, right? React 19 and Next 16, for example. Now over here, you would see that inside here, I have added a new option called node options as inspect break flag. Now the reason I'm doing this is because I want to show you exactly what's going on inside Node.js server, inside React as it's happening, right? So, and that is how I also studied it for the most part. So I'm going to start this server over here, and you're going to see that it's waiting for us to, attach the debugger first. So in order to do that now, I'm going to go to Chrome, inspect, and I'm going to attach the debugger. You can see that it's running on 9230 right now. So I'm going to inspect that, and you can see that it is something which is working. All right, I might have to restart it. Just give me a second, because I'll just try if I have the same breakpoints available or not. All right, let me check if this works or not. And yeah, it works fine. Okay. So we can move forward. So I already have a bunch of these breakpoints already established, but let me first of all show you what's going on, right? So imagine that this is the only code that we have. I just started a regular Next.js server on localhost 3000. Let me open this in the browser as well. This comes with a single page which has this click as a button. And when I click on this button, you will see, let me just bypass this for now. You will see that a request is made, a post request is made to localhost itself, which has some data going on, right? So let me actually show you what the actual code is as well. So this is a simple page, right? So it only has use server. It has a debugger statement which we can remove. It has a console log 1, and it has a math.random over here, which it returns, right? And when I click on this function is called from the server side, right? So this math.random is running on the Node.js over here. That is why you also see this 1 when I press on this button, right? So if I keep pressing on this button, for example, you'll keep seeing 1 in my console log, because this is the code which is actually running in Node.js world. And inside these, you will see that this is a typical React server function call, where I have no clue as a user, as a developer, what is going on. I just create this as a function. I have this function, and this automatically starts to run. Right now, let's just take a look at what's happening inside this function call. So you would see over here, first of all, this is a post request on the same page where you have defined the function. So that is one thing. Second thing is that you will see that this request has a very important thing called next action. This is the value that you want to copy, and this is the value that will change across every action that you are running. That is why this value, for example, if you see the shell.ts, you will see that this is hard coded over here, right? This is another website that is on Vercel, which is vulnerable, because I wanted to also test out WAF of Vercel. I'll show you that by the end of this video. So this is a value that will trigger this next action, and you need that because otherwise, because if you don't do that, then the attack itself does not work. Now, what happens here is that if you look into the payload, you will see that the raw payload that you are sending in this case is just a $T, right? And this $T is basically nothing, but it just means that there is no argument. There is nothing going on inside the function call, because you can see literally when I call this handle submit, there is no function, there is no argument that we are accepting, right? So it's just an empty function call directly to whatever function is defined on this route. But anyway, we are not really interested in doing this. We are interested in crafting our own payload, crafting our own stuff, right? Now, if I do something like this, let's say if I cancel this request, and if I do something like, the same thing that we are doing right now. So if I have, for example, this $T over here, right? And if I run this, let's say if I remove this, and if I run this, you will see that we get the same response over here that we got from the server actions, right? And this is our math.random value. This value that you see is the math.random value over here. Now, obviously we can start playing around this React server component, and you'll start to see that it starts to break sometimes here and there. For example, let's say if I just pass a string instead of an array or instead of an object, you will see that now we are started to get some errors. Create list from array like called on a non-object and so on and so forth, right? So this is what you start, this is where you start to poke around, and this is where how you start to figure out. You will see that in case of objects, it will not crash, right? So again, in case of object, it just works fine. So what we have to do is, first of all, we have to understand that what exactly is this payload? What exactly is going on here? And in order to do that, a simpler way, instead of me explaining you the whole React server architecture in general, is to show you how this works, right? So let me enable the debugger points that I figured out were relevant in my debugging and in my understanding as well. And let me show you the journey of this request. Let's say I hit this, right? I think we need a little bit more parameters in the journey because I've removed some of these, let's see, some of these endpoints, right? So let me add an endpoint over here. Let me add it over here. Let me also add it maybe, yeah, I think that should be fine. Let me just show you the request again. And before that, actually, before going into the code base, let me actually show you what's happening. You see this console log 1337. If I run this, you will see that I get 1337 over here, which is basically remote code execution, right? And that is what is happening. That is what is wrong in this whole thing. For example, I can do, once I have this, I can do something like fetch to evil URL. And then, in the env, I can just pass in like process.env, the whole thing. Basically, I can get the process.env and I can pass it in a network request, and that is how I can exfiltrate the data. But in this case, I mean, just running console log 1337 should suffice. I mean, you will get an idea of what's going on, and you can see like you're basically able to execute arbitrary code that the user can specify on the server. Now let's see how the journey of this request looks like. Let me enable this payload breakpoints again and hit this. All right, so you see that there are certain phases in this journey of, when the payload is sent. You see that over here, we are sending two payloads. We are sending two lines basically inside a form. First is a 0, which is a 0 chunk, and this has the value of this whole thing. That is the string that you see over here. And then there is a first chunk, which is this first key, and it is a value, the special value of this $@0, which means that it's basically pointing back to the same chunk, right? So the first chunk is pointing back to the same chunk itself. Now what's happening over here is that you see that this initialize model chunk is one of the functions inside this React server, which is called for every single chunk that you pass in, right? So even if you have, for example, even if you have 2, 3, 4, 5 more chunks over here, it will be called for every one of them. Now inside this, you would see that React does something interesting. So I don't understand why they do it in the way they do it. Obviously they'll have their own reasons, but the way this works is that they construct a raw model of the, whatever value is passed, and they construct a very weird thing called a value, which they call as a revive model's return value. Now let me show you what this means and what this looks like. So you see that raw model over here is just nothing but a parsed version of whatever payload we are sending them, right? So far it's safe, right? Because JSON parse obviously is safe. You can't do any sort of code evaluation with that. But the value over here, if we go inside this revive model, let me see if we have breakpoints inside this or not. Not really. So let me add a bunch of breakpoints over here. Yeah. So inside of revive model, you see that what we do is that we sort of construct an object, and for whatever object value, so we construct this object again. Basically, we reconstruct this object, but with a twist. What we do is that we look into every single value that we find, and we see that if it has a special identifier, this dollar symbol basically, and it has a number associated with it, that means that the value of this property actually depends on something inside the chunk that is yet to come, right? So that is where the server function call and the, asynchronous and stuff like that comes into picture. Like you can stream the input and output and all those sort of things that React Server Components promises, comes from the fact that I sent this chunk before I had this chunk from the user side. So this, what it basically means is, you see over here, if I can explain quickly, For every single field, it's gonna run this function, this revived model. It'll run it for every single field inside this. It'll run it for then, it'll run it for status, reason, value, response, and then inside prefix, inside form data. So it's a recursive function. You will find this later. But what it's doing is that it's trying to get value of every single field that it encounters. And if the value is string, it then parses it further. Let me add a breakpoint over here. I'll show you. Otherwise, if it's an object, which in this case we have for response, it will go inside this block. Otherwise, if it's an array, it will go inside this block. But it's not an array, so it will not go inside this block. It will just stay inside this object area, right? So let me just, we have the breakpoints. So let me just play this. So you see that for the first object, because this whole thing itself is an object, it will jump directly inside this for loop for objects, right? It's not an array, it's just an object. So we'll go into this loop. Now what happens over here is that you recursively keep on calling this for every property, right? So the next time, for example, this is called, you will see, let me just play this again. You will see that the next time this is called, you will see that the value now, the key is then, the value is this proto thing, which is what we passed over here, right? The first key and then this value. So based on this, because now this is a string, it'll go and it'll parse this model string. So let me just play this and let me actually jump inside this parse model. And you will see now that based on the value, like, because this is like a dollar symbol to start off with, if the value starts with a dollar symbol, it has a special meaning, right? So if it starts with a dollar symbol, you do this whole thing, a whole bunch of things. Otherwise, you just return the value. If it's like a normal number, like a 0 or a resolved model, or even something like this is also just returned as normally, right? Similarly for prefix, but not for get, because again, get starts with a dollar symbol. So in case of dollar symbol, what it effectively does is that it calls, let me see. It basically calls this part, right? So in case of $1, you will see that it's not matching. 1 is not anywhere near here, right? So we just have a dollar symbol as a value 0, and then value 1 is 1, because value is, okay, the debugger is probably pointing it to the wrong stack trace right now, but the value is right now just 1, right? So it will not go inside any of these special blocks over here. So let me just keep playing it. Let me just keep pushing this over here. And let me actually add a breakpoint on the value as well, right? Great, so let's just keep going on. Let's just keep going on and let's just wait for the final value that we get. Right, so this is the get that we have, which is like an internal object. Now we'll start to construct the object from inside out, right? Now if I keep playing this, you will see in the next one, we have the form data now, which has a get null. And if I keep playing this again, you will see that now we have reason, status, then, and I think something is wrong. I think I messed up something, because this should also be null. I'm assuming that we missed $1 or something somewhere. Let me just play this back again. And let me just run this again. Yeah, something messed up. That's why, you can see like we also did not get it 1337. In fact, we got 1 there. So let's just play this back, because I want to show you the real object. Let's just keep playing. Let's just keep playing. And let's just keep playing. Okay, so let's just wait for return value to trigger again. And here we are. So get is null, and then we have form data with get as null, and then we have final object, and now you can see that then is also null. So what's going on over here is that if I understand React properly, you see that these properties start with $1 and a chunk number, right? And that chunk number is not there. It's not parsed yet by React, because it's obviously sequentially parsing the chunks. So what it does is that it just blanks them out. It'll keep them as null. That's why you also see that inside this get, it's null, right? Even though this has the value of whatever, this specific string, but the rest of the values are still there, right? So it'll just keep rest of the values. Now the attack is this. The attack is the fact that you're able to specify these underscore response and underscore form data and underscore, these sort of things. That is the first problem that is there, that React allows you to specify these values for some reason, right? And then it by mistake acts on these values as well. This is the first problem. The second problem is that React allows you to specify these parameters, these then and these constructor, and so on. Let me show you where the problem begins. Now, once the second chunk comes into picture, so right now this is our first chunk, right? The first chunk has resolved. Raw model looks something like this. Resolved model, is this. Raw model looks something like this. This is actually wrong because, the debug, this is like obfuscated code. So it's also overwriting the variable names that is there. So that's why it's like slightly wrong. But raw model initially would have been clean implementation. It will just have this string. And then once this value has run, it has updated raw model again and again, over and over again, because the value finally is just like raw model. In fact, I think value and raw model are same objects if I'm not wrong. Yeah, so you can see value and raw model are effectively pointing to the same object in the memory. And obviously, like, it's slightly difficult to do these things with obfuscated code, a little bit of obfuscation, but it's mostly clean, right? So we can still make sense of the things over here. So let's keep moving forward now. So now what you see is that we get our second chunk, which is this $@0, right? Which is the second chunk. Now what this means, what this $0 means is basically you're pointing back to this chunk again, right? And I've not spent a lot of time understanding what or how and why does React creates these dependencies amongst chunks. But what it basically exploits is that this call or this thing can now go and it can wake up the placeholders which were supposed to be filled with the presence of the first chunk. Right? So this $1 effectively means nothing, but it's saying that wait for this object, whatever this is, to come into the server and then go to these properties inside this object, right? So to give you an example of, a genuine payload, how this might look like is probably something like this. Let's say name, Mehul, and age, 27, for example. So if I had something like this, and then I had $1, and then let's say name, full name of user. So what this effectively means is it's waiting for the first chunk to come in and it will go and pick up this property. Similarly, if this was $1 and age, it will mean that wait for this chunk to come in and then go pick up the property. So what React is doing is using this colon as a symbol, as a way for going and picking up the properties inside that specific chunk that has just come in. But the problem happens is that there is no validation at all of any sorts, like what property are you actually accessing? Does that even exist on the object? Or is it like even legit? Like, can you access proto or these constructor, which actually relates to eval, right? So let me show you where in the code base exactly that happens. So let's say that we keep playing over here. We do the same thing. So we construct the same raw model of the second chunk. This time this is interesting, right? Because now we have the string as $@ and 0, right? So this is definitely a string. So we go into this parse model string directly. Let's just jump into it. Our values, first letter is definitely $. So we jump into this. And the second letter is @, right? Which has again like a specific use case. So if you jump into @ part here, you will see that we get the object first. Object is something which is basically, just the number that is there, right? So if you hover over this value, you will see that object is 0 because it's parsent value.slice2, which gives us 0 into base 16. So I'm assuming that basically a technical attack would also be fine if you do something like this. I'm assuming because it's doing like base 16 over here, right? And then you have this get chunk, right? Which is the original response and then the chunk ID, which is going to be 0 in this case. Again, this is obfuscated code, so slightly it's pointing to the wrong object right now because it has not been computed yet, but this will give you the chunk 0. Now, once you have this chunk, React then starts to act a little weird and starts to start calling these wake chunk methods, right? Because now we have the chunk and now we have to go back and we have to wake them up. Hey, you have your value now. Let's just go ahead and let's just fill that value. This is where the magic happens. See, this object is basically nothing. It's just a blank object. It's nothing. We are passing nothing, but we are still trying to access some properties over here, right? So if I keep playing this, you would see that at some point we get into this part called wake chunk, which has this resolve listeners and chunk.value. Now this is very critical. This is where the vulnerability starts to creep in, because you see that this resolve listeners is basically collection that React maintains of these dollar symbols, right? So wherever in the fields, for example, even if you have like a new field over here and you have written $1 here, it'll go inside this resolve listeners, because these are listeners that are waiting to be resolved by the next chunk when it comes into the picture. Now, as these chunks are resolved, you will see that it also gets this chunk.value, which is again interesting because this is the value of the first chunk, the chunk which we have just passed right now, right? And if you go inside this wake chunk, you will see that this is just a for loop which just iterates over these listeners and it calls them with values. It is even safe so far. Let me go inside one of these chunks values and show you what the callback is. This is what causes remote code execution, the inability to clear out what exactly property are we accessing. Look at this stupid logic over here that we are implementing right now, where we get the value, right? And we have the path, right? Which is again split with the colon. So whatever you're specifying over here, split with the colon, and these values are recursively applied to these in order to extract out that value. It's recursively applied, right? So what's happening over here effectively, it's saying, just like I gave you this example, that let's say if I had person name type, let's say ID Mehul. Let's say I had something like this, right? And I had this in a legit payload. I had something like person name type ID over here. So what it's doing over here, it's that it's effectively just this path basically consists of one person type ID, whatever I have defined as a separate thing, and it will just keep on going inside this object, what we have passed just now, recursively. So it will keep on, not recursively, iteratively with a for loop. It will keep on going that object and it will assign the parent object, which is this one. It will override the key. In this case, it was then. Let me just revert it back. So it will try to iterate the field you have asked here. It will try to iterate the field that you have asked here inside this object, and it will go back and update the original object. Remember that I showed you that, the object is blanked out for these fields. It's null, right? That is where it has to fill back the values, right? And this is where the problem happens, because now if you see that let me just step it a little bit and maybe like get to the part where we have the parent object. So now if you see, in the first case, we now have then as a function. And why do we have this as a function? Because you see that we have said that go to the object that we have just passed you, go to that prototypes chain. This __ proto is a special prototype chain which exists on objects in JavaScript. Read about this if you don't know this. And then access its then property, right? Similarly, as we keep going over here, you will see that when we get to the, let's see, yeah. So when we get to this part, one constructor, this is what causes remote code execution. Pay attention, guys, here. So when we keep stepping on this, you will see that at this point, parent object.key, which is get, becomes function constructor. Why? Why does it become function constructor? Because what we are saying is that go to the object that we have just passed you and access its constructor 2 times. You know what that means? That means, let me show you. Let's say if I have an object X, which is just a promise, right? This is what is the value, right? So what I'm saying is that go ahead and access its constructor, which is just a function that can create promise, but then access its constructor also, which is now a function. You know what you have got over here? It's an eval function, because I can just say something like console log hacked, and I can run this function. Do you see that you get a console log of hacked over here? And the reason you got this is because this is nothing but a new function construct over here, right? You are basically calling just a function keyword over here because the constructor property takes you to the constructor of promise, which is the promise function first, and then it takes you to the function object itself. And now you have to somehow get the remote code execution. It's not still RCE, by the way. You have only assigned what you have done right now, although it's a blunder, but what you have done is that inside the memory, this then suddenly has changed from a string to a then function, like a real then function of this promise. And this function, this form data.get, has actually changed to a function that will just eval anything that will be passed inside this. So anything you pass inside this argument now, and you call this get function by mistake, if you do that, then it will get remote code execution. And that is exactly what this then does, right? Because you would be thinking about that, what is this then and why haven't we played out this one yet, right? And that's what we are coming up now. So let's just keep going, right? Let's just keep going. Remote code execution still hasn't happened. If you go back to my console, you will see that we still did not get 1337 yet, right? Still, the code has not executed. So we are still left to go. Let's say we keep on going over here, right? Right, so let's say we step it over a little bit more, and you can see now that now we are inside this chunk prototype.then. Now this is a call which was made because of this then, right? Because you were able to modify the then of the function itself. Now this is the call that lands us into this chunk.prototype.then section, which then if you hover over this.status, you will see is as resolved model. And this is why we pass this status as resolved model, because if you don't pass this, then this initialize model chunk will not be called, and this rest of the part actually fails the execution. You can try it out on your own also by messing around with this resolved model field. So it's very important for you to pass this. It's very important for you to pass this. Reason can be anything. It's not important that this has to be 0 or anything. And the value also has to be at least $B. It can be this $B. This number is not really required. You can change this to anything. I mean, any number basically, or even any string. I think it will work fine as well. But once we have, because of this then, once we are inside this chunk.prototype.then and we get inside this initialize model chunk, you will see that we are back in the same function that we have started so far, right? But the difference this time is that this chunk that we have, this chunk is controlled by us, right? This chunk is controlled by us now. So if we go ahead, you see that the value, the chunk.value, which is what we specified over here, right? This is the reason that we specified, because now we have created basically a chunk that is fully controlled by us. It's not controlled by the end, whatever, like the React server component. And this resolved model in this case is a then with a $B of 1337, right? And we have seen that the revive model again, because this will pass out as a string, you will see that inside the revive model, let's say if we go into this, you will see that the value is then and $B 1337. And that means that it will go inside this parse model string now. It's an object, right? So it will first go into this, then it will go into this string thing, $B 1337. Then we'll go into parse model string. And over here, now we have a special meaning. Now we have a special meaning because you see that the first symbol is $, but the second symbol is B. So B in this case is actually this thing. And if you look at this closely, what it's doing inside React Server Components code base, it's taking the first two characters, which is this one, and then we had like a 1337 over here, and it's parsing this as an object, and for some reason it's appending it to there, right? But it doesn't matter because we already have the workload or the exploit inside console log, like in the first thing. So you might as well just pass in like a comment over here, because what you're effectively getting at this point is basically response.formData.get, which again you have polluted, because remember, you control the whole chunk, right? So you have this response over here. Form data you have already passing in. Get, remember that it automatically changed this to the function constructor. So this form data is not actually the form data that React is expecting it to be, like a legit form data. It's a form data that will invoke the function. It will invoke it'll just create a function like this. But remember that this is still not remote code execution, because what you are doing is that you are creating this value is basically what this value is something like this. You still need somebody to call this function, right? And the way this happens, if I step forward over here, you would see that we return the value, which is this then function, but you see that this then is then evaluated internally by JavaScript as a promise. And JavaScript has a feature, or in this case, which is used as an exploit, is that it will automatically run the then sequences of a promise, right? So what's going on over here is, let me actually show you. Let me see if I can get it before. Okay, it actually executed, but if we run this again, what you will see is that this is a state where you have created this value function. Basically, you have created this function, which is a payload, which just once this is executed, this will do remote code execution. But this payload is actually called with the then function. That is something we have also exploited right over here with this prototype chain. With this value, sorry, not the prototype chain that is used earlier. So this value, you see that, let me just show you again. So this value, if we see at the very end, let's just keep jumping. So here we are again, right? So you see that this value that we have is a then, right? And this then is a function which will, when it will execute, it will actually run this 1337, right? Because if you look into this, let's see if we can find this or not. Yeah, so if I open this function location, you see that this function points to that, right? And you can exactly see what's going on. We have this 4919 for some reason. I thought it should be 1337, but anyway, so you see, this is this then, which points to $B. Oh, I think it's 4919 because parse int 16. Yeah, because it's in base 16. In base 16, 1337 is 4919, and that's why you get this function like this. Because remember that the value is resolved to be $B, which is read by formData.get, binary data, exploiting that fact. Get is already overwritten with the fact it's the constructor of this, whatever you are passing over here, which effectively becomes a new function, and you make that function. But the exploit is still not done. Because you see that until and unless somebody calls this function, just like I mentioned again earlier, until and unless you call this value, it will not be executed. But then we finally take help of the fact that in JavaScript, then chains are automatically evaluated by the runtime itself. You don't have to call them in case of promises, right? And yeah, that's what happens. So, if you keep going down, for example, let me show you, if we just keep stepping down inside this, you will see that at some point we will go inside Node.js internals. See, now we are inside Node.js internal async hook, because now it's going to evaluate the then, right? So you can even keep going down over here, but there is no vulnerability here because this is how it is supposed to work. This is all now Node.js internal code base, but we have still not gotten the 1337 code log, right? Because it's yet to evaluate the final .then, which triggers the vulnerability. So if I play this now, you will see that we get 1337 finally at the log. That is why it's critically important that if you name this something wrong, you will see that let me just do this, you will see that there is no vulnerability, because this final then is what triggers the code. This is what triggers the vulnerability. So you can have the whole code base running, but if this final then is then 5 or something else, you will see that the code will not run, because this is the console log coming from here. But if you change this to then, it'll run and the server is compromised. extremely sophisticated attack, I would say. I mean, it requires a lot of tinkering if you are doing it brute force. I would say if somebody who even knows like how React server components works, I mean, they would probably have a better idea in constructing this attack. But I mean, this is something that will take a lot of time to think out loud. It's even harder to explain, right? Even after this is there, and I've spent like multiple hours myself understanding this, setting up breakpoints. That's why I created this video. But this is very cool. This is very cool. So you're exploiting like 2-3 things in a similar way. First is like, the ability that chunks can be pointed. That is one thing. And this creates like a placeholder. So this will automatically become null. This will become null. Second is the property mishap lookup, right? The fact that React just automatically just points to any chunk and it is able to just reiterate over, whatever property the end user is passing. You are accessing the property directly. That I feel is the biggest problem in this, right? And once you have done that, once you have polluted the chain, the prototype chain, to pass back to myself, then I can create a chunk which I'm in fully control of. And that is why this includes this response, underscore response, and so on, because this is the minimum viable payload that you need in order to run the attack, right? Because for example, if I show you, messing around, let's say if you remove this form data and if you try to run this attack, you will see that you'll get the error, cannot get read properties of undefined reading get, because React's internal code expects the chunk to always have this underscore form data, because you are not supposed to create this in the first place by yourself. This prototype then should not be possible in the first place. This prototype then, basically this allows this to act as an independent chunk. Then the value itself, then this response, form data get creates this as it's an eval function over here effectively. And then finally, because the value points to the ability to read this form data through this binary mode, you're able to trigger a prefix attack. Yeah, that's how the attack works. And if you like this, make sure you leave a like and subscribe to the channel, and I will see you in the next video very soon.